Yeah, I think I'm live. Let me just share my screen with you all. Is my screen visible to every one of you? Let me share my screen first of all pretty quickly. Yeah, I think my screen is visible. No issues. There was some there was some network issue. Let me just read the problem statement. You are given a zero index array nums as index I is a part of L in nums. If the closest non-equal neighbors of I are smaller than nums of I, similarly, okay, if it is a part of L if the closest non-equal neighbors of I are smaller than nums of I. Okay, smaller than nums of I. Similarly, an index I is a part of valley if the closest non-equal neighbors of I are larger than nums of I. Okay, adjacent indices I and J are part of the same hill or valley if nums of I is equal to. Okay, great. Okay. Note that for an index to be part of hill or valley, it must have a non. I have to buy it will be second hand. If you are buying a second hand, go for MacBook. That is best. 55,000 M1 chip. That is the best laptop that you can use in your first year. Take a laptop in your first year. Take MacBook M1 chip. No issues. It's like the best for programming. They will tell that it's 5 years old, like and all these things. But take a laptop. Okay. Uh, Let me see the examples. 2 4 1 1 6 5. There is non-equal neighbor of 2 on the left. No non-equal uh, on the left. Here neither a hill nor a valley. Okay. At index 1, the closest non-equal neighbors of 4 and 2 are 1. 4 are 2 and 1. Okay. So it is a hill. Okay, the closest non-equal neighbors are 4 and 6. So index 2 is a valley like this. 4 is 1 is 4 and 1. So the right hand side is equal. So uh, 1 second. 4 to 1. For 4, 2 and 1, so it is a hill. For 1, 4 and 6. Okay, non-equal 4 and 6. Great. Okay. Then since 1 is smaller than 4 and 1 is smaller than 6, then it is a value. Okay. 6 is greater than 1, 6 is greater than 5. So index 4 is a hill. Great. So index 5 there is no non-equal neighbor or of 5. Okay, 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 great. Okay, understood. So same thing here. Okay, just have nothing. Okay, so I have to do this right. Just if it is like a valley, then it is simple. But the main thing, like the main concept comes when there is equals, right? Okay, no issues. So what we can simply do, simple run a for loop and just like check. Okay, that's it. I don't think it's much hard. It's not very hard, and the answer is equal to 0. Okay, now I have to just run a for loop, right? N is equal to nums dot size, and I is equal to I small than n I plus plus. Okay, now if nums of I is uh, nums of simple nums of I is let's run a loop from I is equal to 1, I is smaller than n minus 1, and I'll update the I later on. So n minus 1 is nothing but smaller than nums of I, and n I plus 1 is smaller than n, I smaller than n, and n nums of I is greater than nums of I plus 1. If this is the case, just answer plus plus. Okay, else if simple nums of I minus 1 is greater than nums of uh, nums of I, and then I plus one is smaller than n. Simple. I plus 1 is smaller than n, and nums of I is also smaller than nums of I plus 1. Okay, both things satisfied. Then just write answer plus plus. Great. It is the case. If simple, the two of them are greater or smaller, then it is a hill or a valley. But what if like the just immediate left and immediate right are not smaller, not equal? So we have to check for the like the leftmost element or the rightmost element, right? So else if just write I plus 1 is smaller than n, and then nums of I is equal to nums of I plus 1. If this is the case, at the right hand side, if it is equal, what we have to do? Int previous is nothing but nums of I minus 1. That's it. And now while I plus 1 is smaller than n, and then I could just keep checking. Nums of I is equal to nums of I plus 1. If this is the case, what I have to do? Just increment the value of I, and if and when you come out of this loop, I plus 1 is smaller than n, and then what I have to do? Nums of I is smaller than, or nums of I plus 1 is smaller than nothing but I plus 1, not smaller than, it's greater than nums of I. Uh, nums of I, first condition, and the second condition is, wait, nums of I plus 1 is greater than nums of I, and I have to check also the previous value, right? So and then previous value is also greater than nums of I. Nums of I. Okay. Now coming out of this loop, either this condition, or I have to check for the another condition, which is nums of I plus 1 is smaller than nums of I, just this, or previous is smaller than nums of I. Let me do this. Yeah, I think now it's visible. If this is the case, just increment the value of answer. Okay, just return the answer. Simple. And coming out of this loop, I plus plus. Okay, 1 second. Now the full code is visible. Now return answer. Let's see if it is working or not. In this field num search size, I is sorry, and answer is equal to 0. Huh. Compilation error. Just a second. Num size greater than this. I plus 1 is smaller than n, and and yeah, it accepted. Let me just submit the code and see if it is working or not. Yeah, it accepted. So see, what am I doing is doing a simple thing, just running a loop from the like starting till the end, and if it is a valley and if it is a hill, I'll increment my answer. But what if it is not? Then I'll check for the immediate, like the next right element which is greater than the like this element also, like the previous element also, or it is greater than the previous element also. Just simple. If this is the case, just increment the value of I. If not, then like just continue and do nothing. Okay. I think my approach is visible, like clear to every one of you. This one is the main concept of this question. Just check for the immediate right, that it is greater than the current element or not. Like this element, if previous element is 4, then this element is also greater than this element. If the previous element was 0, then this element should also be 0 or smaller than 0. Then only it should work. So that was the approach. Thank you so much for watching.